Okay, so we're still working with proportional sides of triangles showing similarity. And so this is a nice theorem. We can, if you look at this picture here, we can see two overlapping triangles. We can make the case that these two triangles are similar, so CBD and CAE. But what we have here is a triangle proportionality theorem, sort of skipping that process of breaking these apart into two separate triangles. And what this says is that if you have a line through any triangle that is parallel to one of the sides, then it separates the sides into segments of proportional lengths. So, for example, this one, see how BD is parallel to this base AE? That means that BA to CB is equal to DE to CD. So small to large, small to large. And that's it. That's a theorem. So, I don't know, let's say we have 2 to 4, then this would be 4 to 8. Notice we multiply this by 2, we multiply this by 2. Obviously, these numbers are way off, but this shows that proportionality that we have 1/2 to 1/2. That ratio is the same. Scale factor is the same. So here we have an example. In this triangle, we can see that EF is parallel to HL, and we get that EH is equal to 9, HG is equal to 21, FL is equal to 6, and we want to find LG. Well, we know, because of that last theorem we just looked at, that EH to HG is going to be equal to FL to LG. So EH is 9, HG is 21, FL is 6, and LG is LG. We can reduce this fraction, so we get 3 to 7 equal to 6 to LG. So we get 3 times LG is equal to 42, and we can divide both sides by 3. So we get 42 divided by 3, which is 14. So LG must be equal to 14. And that proportionality holds up. You can see that we can divide 6 divided by 14 and reduce that to 3 to 7ths. The scale factor holds. Another theorem is the triangle midsegment theorem. And so this says that the midsegment of a triangle is parallel to one side of the triangle, and its length is half the length of that side. So, for example, in this picture, we can see that B and D are midpoints of the sides AC and CE based off this diagram. So that means that BD is parallel to AE, and BD is half of AE. So if BD is 5, AE must be 10. So let's take a look at some of these. So ABC has vertices -4, 1, -8, or 8, -1, and -2, 9. DE is the midsegment. So we want to find the coordinates of DE. Well, the midsegment goes through the midpoints. So these are just the midpoints. So D is the midpoint of AE. So the midpoint there is -4 plus 8 divided by 2, and 1 plus -1 divided by 2. So D is equal to 4 divided by 2, which is 2, comma 0. So this point is 2, 0, which looks fairly accurate. E is the midpoint of that other line, and so that's -2 plus 8 divided by 2, and then 9 plus -1 divided by 2. So E, simplifying this down, gives us 3 and comma 4, which looks, again, pretty close, yeah. We want to verify that AC is parallel to DE? Well, remembering that D has a 0.20 and E has a 0.34, all we need to do is show that they have the same slope. So the slope for AC is going to be equal to y2 minus y1 over x2 minus x1. And so the y values are 9 minus 1, and the x values are -2 minus a -4. So this gives us 8 over 2, which is equal to 4. So this is 4 over 1. And then the slope for DE is equal to y2 minus y1 over x2 minus x1. So the y values there are 4 minus 0 over 3 minus 2, which gives us 4 over 1, which is 4. So see how the same slope shows us these lines are parallel. And then we also want to verify that DE is half the length of AE. Well, we want to find the distance for DE. So the distance for DE is the distance formula. We use 4, it doesn't really matter, but I'll do the x's first. So 3 minus 2 squared plus 4 minus 0 squared. So this gives us 1 squared plus 4 squared, which is 16. So the distance for side DE is equal to the square root of 17. The distance for AC is, if we have those x values, we get -2 minus a -4 squared plus 9 minus 1 squared, and that gives us 2 squared, which is 4, plus 8 squared, which is 64, and so this gives us the square root of 68. A little wonky looking 6 there. Now we can actually reduce this because 68 has some, we can break this apart. 68 is actually 4 times 17, so the square root of 68 is square root of 4 times square root of 17. So the distance of AC is the square root of 4, which is 2, times the square root of 17. Notice the distance of AC is twice as much as the distance for DE, showing that DE is half of AC. So distance formula, slope formula, midpoint formula, all coming back to help us with this new material. And so that's it. So this is a really good problem here that kind of highlights all of this. So 2 theorems today were the triangle midsegment theorem and then also the triangle proportionality theorem. So they're fairly straightforward theorems, but you can easily get them confused with some of the other material. So make sure that you review them and you're comfortable with using them in different types of problems.